if there are no other introductory comments, I would like to give the word to Elizabeth and just briefly introduce her topic. So before forecasting mortality by cause of death, we wanted to take a look at the dependencies, which causes of death are related to one another, and which illnesses are also related to one another. So Betty, even though she has started about half a year ago, she has already produced like two papers. They're in preparation. One of them looking at dependencies among causes of death, and the other dependencies in morbidities. So for the morbidities, she used the shared data so far because we're still waiting for the Danish data. But for the multiple causes of death, we have the US data that are publicly available. So this is what she's going to report now. So I give the floor to Betty.
I would maybe add, sorry, that that in the SCOR chair, there was planned that there would be one PhD student hired, and Betty is the PhD student that was hired to the project starting in September 2023.
Great.
Yeah.
So, hello. I would like to report today on the topic of the causes of death dependencies and as they appear through the lens of multiple cause of death data. Before formulating the research questions, let me just talk briefly about the data we use. So usually when people die, they got a death certificate where the causes of death are recorded. The death certificate, it consists of two parts. In the first part, the physician records the chain of morbid events that are leading to death, with the condition that initiates this chain on the lowest line. And to the second part, the physician usually records the contributory causes of death, which are not a part of this integral chain of morbid events that lead to death. And in multiple cause of death approach, we assume that any of these causes could cause the death. And why is that relevant? Firstly, it is because it is only the minority of death that happened with single cause. Here we can see an example of the distribution of death by causes in two different countries, in Czechia and in the USA. And in Czechia, it is only 10%, and in the USA, approximately 20%. These figures are similar for the data from France and from Sweden. This distribution does not stay stable over time, but it changes. There are always more and more people who die with more and more causes of death. And this has several implications. Firstly, it has the implication on how the cause of death statistics are built. Because usually, as I mentioned, death certifier records the causes of death, and then they went through some software which selects in accordance with some international rules the underlying cause of death. So death statistics are built. Because usually, as I mentioned, death certifier records the causes of death, and then they went through some software which selects in accordance with some international rules the underlying cause of death. And of course, if there are more causes, then there are more options. And nowadays, the discrepancy between death rates, which we calculate based on the records from physicians and based on the causes that are selected by the automated coding systems, are rising. Here we can see an example for the leading causes of death in the US, that for instance, for dementia, the disparity between these two death rates by cause is approximately, like the ratio of these two types of rates is approximately 0.9. And therefore, it is important to consider that not that the causes of death, they operate independently from each other and compete for one's death, but that they operate together, and then the result, the death, is due to this like several risk acting at a time. So in the past few months, we have been working on several research questions. Firstly, we know that there is a certain dependent structure of causes of death, and what we did, we introduced disruptions to these dependencies. So we selected leading cause of death pairs, and we made them independent, and then we analyzed how this affects the overall cause of death structure dependencies. And then we studied the dependencies by age, and that resulted in a computation of life tables which do not assume independence between causes of death. And this allowed us then identify the ages for which it is most important to consider the dependency between causes. Here on the left side of the panel, we can see the odds ratio between major cause of death groups. The more red, the stronger is the dependency. And we highlight in these blue squares the leading pairs. And for the further analysis, we consider them and what we do. So the motivation is that we see that since the 2000, the odds ratio, so the dependency, the strength of dependency, is not constant. So it changes over time. And we usually do not consider that if the risk of having, for instance, heart disease and metabolic diseases changes, so how could this affect the relationship, for instance, between heart diseases and, say, infectious diseases? So we assumed, we took each of the leading cause of death pair, and we assumed that there is an independency between them. And then we looked how this affects all other possible relations to other cause of death groups. How we approached this problem? We started with a 2x2 contingency table with a number of deaths by 2 causes, and we can perform a simple chi-square test in this table to test for the independence. So basically, we test for the hypothesis whether they are dependent, both diseases, and if we get a certain p-value, then we may reject null hypothesis that 2 diseases are independent. Obviously, for this example, we can reject the null hypothesis as our odds ratio is almost 4. And we optimized the marginal distributions in this table to change the result of the chi-square test that we cannot reject the null hypothesis. Of course, there are many possible solutions how we can do this. And all possible solutions that yield independence between this cause of death, between cause of death that is plotted on the x-axis and on the y-axis, are plotted again on the yellow line. And once we get all possible solutions that can yield independence, then we have to select one to see how this hypothetical scenario of independence affects the cause of death dependency structure. And which one did we select? We selected the one which cost minimum relocations of death within the contingency table. And we consider that one to be the most probable scenario. And on this table and on the table on the next slide, there are the results. Let me explain how we can read these tables. So in the column headings, these are the leading cause of death pairs. And here in rows are all major cause of death groups. And in the table, for instance, this number, 0.88, it tells us the odds ratio, the ratio between the odds ratio that is observed and the one that we get between the first disease and disease in the row if we assume independence between leading cause of death pairs. So for instance, if metabolic diseases and respiratory diseases would be independent, then we can say that the risk of having metabolic diseases and infectious diseases would also decrease. And most pronounced changes are seen if these highlighted cause of death pairs would be independent. They include mental diseases and endocrine diseases or metabolic diseases, and also other respiratory diseases. Of course, for the mortality analysis, it is very important to include the age dimension in the work. So here is the development of associations between causes of death by age. Now we do not work only with those pairs that are dependent, but with all leading causes of death pairs. Interestingly, it is only the mental and endocrine diseases for which we can say that the strength of association is getting stronger with age. We can also calculate the age-specific probabilities of death from both causes. And we can see that the pairs that include mental diseases, that the risk of death with these pairs, including mental diseases, increased over time. And it happened especially in the ages between 50 and 70, as we can see, for instance, at the example of mental and endocrine diseases and mental and heart diseases. And we know by the multiplication theorem that we can say that death from I is independent of death from J if the following is true. So if the probability of death from both diseases equals to the product of probability of death from either one disease. And if we compute a ratio of this, we can see that with age, there is a convergence towards 1. So at the very highest ages, probably the two diseases or the death from disease I is independent from J. However, that is not true for the youngest ages. So we started with the fact that the diseases are dependent, and now it is a question how this could affect, or how important is that in mortality analysis. So usually when we calculate, for instance, multiple decrement life tables, we assume independence between decrements. But there have been several methods proposed that do not include this fundamental assumption. They have been proposed by Manton et al. In the 80s, and they are called the pattern of failure life tables. So the probabilities are estimated in a following way, that we start with the death by age and by causes. And if we would have hypothetically only 3 ways how a person could die, then we could distinguish 7 different patterns. So either a person dies with a single cause, or with each pair independently of the order, of course, or with all 3 of them. And this row equals to the number of deaths. So if we count them in this decrement, we do not count them here or here anymore. And to assess the total health consequences of each of the major cause of death groups, we then use a tool called eliminations of patterns of failure life table. That is same, or in principle, it is same as this cause of death elimination life table. So we assume that people do not die from certain causes, and then we see how the life expectancy changes. But here, we do not only rely on that underlying cause of death. So a probability, age-specific probability by from age-specific probability of death from a certain cause if patterns that include cause B can be eliminated. And it is estimated in the following way, and then we can calculate life tables and corresponding life expectancies. Here on these figures, we show the results. This is the gains in life expectancy if we eliminate these major cause of death groups as causes or as patterns. In the relative point of view, the greatest underestimation, if we consider only causes, comes in mental, endocrine, and infectious diseases. And these, the importance of these diseases has also an interesting age-specific pattern, which is shown here. So let me explain what we see on these plots. It is a ratio of the age-specific probability of death if we eliminate each of the disease in a cause or in a pattern. So basically we can say that the darker the region, the more important it is to consider the causes of death that they contribute to the risk of death. Or in other words, that the underestimation of importance of these diseases is the greatest in the darkest regions. As mentioned previously, it is the multiple causes of death. They are very important if we are working with mental, metabolic, and also infectious diseases. And we can see here several period as well as cohort patterns. So for instance, here the mental diseases, what to imagine under this epidemic. It's not epidemic, but the causes of death that are most important here are the substance use disorders, but it is not only substance use disorders, but also the mood disorders, depression and anxieties, and so on. And also it is the dementia. So it is the, and what is interesting is that we are dealing with ages that are below 80, and we see that the importance of dementia rises even in those younger ages, which we do not see in the underlying cause of death analysis. Here in metabolic diseases, it is not only diabetes as expected, but this is also some nutrition deficiencies and obesity. And last thing that is interesting about this figure is the obvious importance of the causes, non-respiratory causes in the year 2020 that was distorted by the COVID pandemic. And we see it obviously in metabolic diseases, heart diseases, and also other disease groups.
Maybe it's good to highlight that these data are for the US.
Yes, these data are for the US, as basically the whole analysis is based on the US data. We have also for comparison data for Czechia, but only since 2012 until 2018. But you can see quite a similar patterns also within these Czech data. And I know that it is usually said that the multiple causes are very affected by the coding, but basically we can assume that if they would not have these conditions, it would not be recorded. So it is like sort of like a baseline of the burden of disease that could be there.
I have a question. Yeah. So you mentioned it's in the mental disease. And the nervous disease, what is included in this one?
Yeah, in nervous diseases, this is specifically the Alzheimer, and it is also Parkinson disease. And it is also some like diseases of brain, specific dysfunctions of brain.
But you mentioned it's in the mental disease.
Alzheimer. It is the code in ICD, the code of Alzheimer is G30, and they put it to this one.
Right.
Yeah, and this is like F00, F90 in the ICD codes.
So you don't include dementia in the mental disease, or you include dementia except Alzheimer's?
Here are certain types of dementia are in here.
Okay, so you separate these two groups.
Yes, there are specific lists how to separate the diseases, and we follow that list and that recommendation in this analysis.
And it's the same ICD classification is 10 for all the periods.
Yes.
Yeah, it's ICD-10 that you're using.
Yes, it was implemented in 1999. So
Yeah, so it's
and we saw previously that there are some changes since the year 2000, and these changes can be summarized in the following way. This figure, it shows the difference in gain that we get if we eliminate these major cause of death groups in 2000 and in 2019. So basically this bar, if it is positive and that high, it means that the gain nowadays would be much greater than the gain if we eliminate the mental disease back in the 2000s. So we see the declining importance of heart diseases as well as neoplasms, but on the other side, rising importance, as I also already mentioned, of endocrine, mental, and nervous diseases. And what is very important is that we see that it especially can be observed if we include all these multiple causes of death to the analysis.
Just one more thing. Okay. Where do you include suicide?
Suicide, this is an external cause of death.
So it's not included
And
in the
we do
mental
not work
whatever.
with external causes of death.
So it's, you just exclude all the suicide. And
Yes.
Okay, and the poisoning side also like all the external ones are excluded.
External causes of death are excluded.
Okay, because just think that many of these depressive or mental health actually they die from this kind of external causes. Actually. So it's not classified as mental health.
For instance, if a person dies from overdose,
Yeah.
then they have substance use disorder, and it is considered to be a mental disorder. So it is included. But if they die from suicide, then it is not a mental disease.
Yeah.
so so you eliminate this kind of external when they appear as a leading cause of death or anywhere.
If they appear, or if a person died from external cause of death, then it is not.
So if in the leading it's written external, then whatever is outside underneath, then you anyway exclude that.
Yeah.
Okay.
So it's only considering the primary cause of death, not the secondary ones. So the classification of the cause of death. You are taking only the primary cause of death. Because in the death certificate.
No, she takes everything, but then for selecting the individuals in the data set, you take only the leading cause of death. That's what I understood. Maybe
Yes.
wrongly. Okay.
Yes, but we include all of them, but not death that happened, for example, due to transport accidents.
Yeah.
And so on.
But, And for example, overdose with opioids is included in mental health.
Yes.
Okay. So that's maybe why we see an increase in the mental health causes rates.
Yes, but it contributes, for example, only by the 35%. The rest is divided between, as I mentioned before, these types of dementia, of premature young dementia, and the mood disorders and depression and anxiety and this kind of stuff. And now I would like to summarize the findings. So firstly, firstly, what we did, we saw that if certain causes of death would be independent, that it will have the broader impact of the overall dependency, and it applies especially for metabolic and mental diseases. Then we saw that there are certain shapes of dependency between causes of death, and lastly, we estimated or we highlighted the ages for which it is especially important to consider that the risk of death from diseases could be underestimated from particular cause of death groups if they are not included in the analysis and if we work only with the underlying cause of death data. So that's all from my side, and I thank you for your attention.
Do you have any extra comments or questions?
Just it was a lot.
Can you come back to the summary? I do remember in one of the slides you mentioned that removing the dependency will have a greater impact than removing some causes to remove some causes. Is that correct?
Yes, so maybe you are talking about this one.
Maybe one earlier, but let's can we look at this one too? Yes, okay. Yeah, this one. When you eliminate the pattern, it has a greater impact than eliminating the cause.
Yes, this is like natural, but it is about the ratio between this bar and this bar.
Mm-hmm.
And the ratio is the greatest for the diseases that I mentioned. So we sort of like oversee the impact the most in mental and endocrine and infectious diseases because this gain is approximately then 5 times higher. And for the future work, you can also ask the questions sort of like not if we eliminate all patterns that include a certain cause of death, but for example, you can consider the order of the causes. So what would happen if people would not die, if they would not transfer from one disease to another disease? So if there would not be that second one, that is actually the further work.
Okay. So the pattern is the association between causes. AB or BC, those are patterns.
Yes, it is all possible combinations regardless of the order.
Yeah. So when you compare those two, like you are comparing the impact of dependency and the imbalance.
So in the small one, you basically treat, as in the multiple determinant life table, each cause independently. In the pattern, you assume that there is a certain possibility that one cause could happen with other cause, and then therefore eliminating one, you eliminate also the dependency with respect to the other one, and so the impact is stronger.
Yes.
Okay.
So why heart, which is the absolute term, is the widest one? Why you don't stress this as an important?
Well, firstly, people die very often from like one specific respiratory disease and one specific heart disease that are immediate causes of death. These are the heart failure and the respiratory failure. So that's probably what is increasing this impact of heart diseases. But again, you could work in a way that you do not count these specific causes, and then you can estimate the results.
Can you just go back to the effect of dependency through the age? And what is your conclusion here? So you were mentioning that mental and endocrine, the dependency becomes stronger through the age by age.
Yeah. This is the reference line. So again, if it is around this line, then there is no dependency. It is similar as in odds ratio for this indicator. So these ones are not dependent at all. And this, it stays, the dependency remains non-random overall through the whole age range. But then for this one, it declines similarly as for this one, it declines. And of course, there is an ongoing discussion on why does this happen. And one of the possible explanations is that people, if a death happens like 90 years and older, then the death certified just say that, okay, it was normal to die, so I will not bother myself to fill in the death certificate so properly. But the other explanation, possible explanation, could be that it is a condition to survive to such a high ages, not having multimorbidity, so not having several diseases.
And why CVD is cardiovascular and heart? Why it became positive and then negative for the age range? To have a stronger association towards 80.
Uh-huh.
And then people are more dying from one or the other cause than both. And it's the same reasoning that you are having. They were under, they don't bother to kill.
Yes, maybe. Or it can also be that for these, like the ages where it is independent, so they could also code different codes from this one. So this also includes, if each of these major codes of these groups, it includes certain causes. So it can also like be divided, that they code more these ones within the dependencies, within these ones more, and within these ones more. And therefore it has this shape.
I ask you a question. Can you go to the table in which you show the HPAT, the failure after the mountains? Yeah. So I have just a question about the importance or the difference in the importance when you think about the cause independently and when you think in this kind of setting. And my question is mainly due to the number of causes that could appear in the death certificate, and whether some causes that actually appear with many more other causes have the tendency of being naturally more dependent to other causes only because they are more often there than others. So I don't know whether an analysis on the number of causes that actually appear in the death certificate could somehow shed light on that possible bias. I don't know whether I was clear or not, but let's say the point is that if it happens that heart disease or heart attack is normally connected with many more causes than I don't know, like dementia, let's say, or maybe it's the other way around, probably. Then it's natural that the dementia would be much more associated with other causes of death than heart disease, because it appears to be more often in the death certificate with many more other causes of death. I don't know whether it's.
Yeah, maybe if you calculate the associations, then you usually have to also consider number of people who do not have these diseases. And in these Manton life tables, he does not include this fact, because the number of people who do not have either one disease, it affects the associations similarly or samely as the number of people who have them, right? Because you have to calculate both of it.
Multiply them in the denominator. The
Okay.
have both. Look at the formula, like
Yeah.
the very top and the very bottom. You're actually looking at this interaction, the number that have times the number that don't have any of them. Like this.
So if it doesn't matter whether certain cause of death appear more often in the certificate with others than with respect to someone that is there alone or just with another one.
Yeah, in the life tables, it is not about the strength of the associations. It is just about the co-occurrence. So if they co-occur randomly, then even this death we count similarly in the upper elimination. But here it plays role, as Stefan said, how many people did not have certain diseases.
Is there any
consistency over the time.
This that we count similarly in the pattern elimination. But here it plays a role, as Stefan said, how many people did not have certain disease.
Is there any consistency over the time in reporting causes of death, for example? Is there any potential bias in the data itself?
Yeah, as I mentioned at the beginning, there are changes in time in how many codes are recorded, and then of course this gives options to the automatic coding system, to the software that selects the underlying cause, which one to select, and this one can then modify the statistics. And basically, in time, there is a difference in the ratio of death rate based on the underlying that a physician considers and that is automatically selected. But this actually justifies the use of multiple causes of death because you are free of that one single selection that changes over time. But of course, I also mentioned that there are considerable differences across countries in multiple cause of death statistics, but we start with the assumption that a physician would not write it there if it would not be in the person, not other way around. So it is like the baseline, that the disease burden is the baseline. And the differences between the countries, yes, they exist, but not in the sense that that they record it to the death certificate if a person does not have the condition.
But what do you do with those cases when before diabetes was not classified as a cause of death, and then they changed the classification, they added as a new cause of death in the death certificate? In this case, how do you deal with the changes in the classification? The same for Alzheimer, like before 2012, there almost no one was identified as dying from Alzheimer, but in 2013, you have a jump. It's a big change in the classification cause of death.
There are certain years when they changed the ICD classification, we know that, but this one we start from 2000, so it is based on a one classification, so on the ICD-10 edition.
I'm talking about clinical classification, because that's basically the clinical record was changed due to the practice of the clinicians. It's not only the ICD code, it's also how they classify on the cause of death certificate. So this one, yes, it's not really related to the classification ICD-10 or 9, because 10 or 9 they can basically transfer like from 9 to 10. That's what we see is we see a sudden change in certain causes of death that really affects the trend analysis that we have.
So the group are very large.
Yeah.
So when Alzheimer is in nervous, by the past it has been also there, and if you come back to the heat map, where you show the, I think the heat map at the end. Yeah, here. Mm-hmm. Yeah, you see some slides becoming darker for the nervous disease. So could be that you have a recording effect after 2015.
Yeah, that's what we see. You see the same pattern that goes up from 2015. This is from Alzheimer classification.
Hard to say, because also at the very high ages, it's becoming very, very dark.
Because before, those people will be classified as dying from other causes because they are not diagnosed as having Alzheimer's. So this is a classification, the diagnostic problem.
Yeah. Still in the nervous disease.
Secondary cause.
Yeah, they can classify as dying from heart disease or cardiovascular disease. It's not necessarily nervous disease because they are not even diagnosed as having Alzheimer's before.
Yeah, but this should do with the data.
Yeah, that's definitely affect the dependence. dependency data.
Is it all males and females combined?
Yes, that's both sex combined.
Does a gender-specific analysis provide different results, or can it be?
I will definitely do this when I come back on the diversification by sex. Yes.
Does your result will change if you exclude those very high ages? Because those death certificates, the cause of death classification in the very high age, like 85 plus, they are not very credible. Here we can just classify people dying from one of the cause, whatever, because they will eventually die from something. Even they just died not from a specific cause of death. So sometimes that's not the same credibility as you have for the younger ages.
Yeah, but that's like the overall problem with the cause of death statistics. That basically, even if you take only one, well, okay, maybe it is this one, maybe it is not. So if you include like all of them and assume that all of them could possibly cause the death, then it could be seen as a possible solution. And if you select just one cause of death somehow.
And also you could see from these graphs with the dependencies that converge at the old ages to this one.
Yeah.
So this independence could be either coming from some mechanism or the other way around, just from picking at random just one cause out of a pool
you just write
of
something.
causes. Yeah. So we cannot be sure what it is.
I think the Danish data would be more accurate with the US or
Well, for Danish data, well, we might have a lot of explanatory variables. So we can have a list of diagnoses. Apart from the death certificate, we can have a history of diseases, and we can also we also apply for prescriptions by the doctors, so that we can detect diabetes type 1 and diabetes type 2, right? Because from the hospital records, you're not able to disentangle them. So we hope that in the presence of more explanatory variables, the history of diseases, we might be able to check at least whether at highest ages the doctors picked up the cause of death at random, or it was more consistent with the history of diseases. Yeah. And like one of the aims of the project is to identify the meaningful paths to death. So based on the multimorbidities and the multiple causes of death, identify the statistically different patterns that lead to death. So we're hoping to get there with the Danish data.
I was wondering that given maybe the big impact of the other diseases, if you might be interested to a bit more. I mean, I don't know if you can split a bit more this group of causes, because indeed, if you look the scale, it seems that it's the most impactful one is the one that goes to 0.7.
Yeah, the codes that are mostly in this category are the genitourinary diseases. So probably it could have something to do with the renal failures and diseases of the genitourinary diseases. This is the most often caused.
Is there any reason? I mean, was there any event that led to I think it was 2010? Well,
Yeah, you mean this one?
yeah. A concentration of death there.
Yes, we are thinking that it is probably connected with this one, with the sudden change that again includes the genitourinary diseases that they said, for instance, I did not find any explanation, like explicitly saying why this happened, but the hypothesis is that they simply said around that time that we will not code, or we will code more genital urinary diseases, whatever. But usually when it is like that sudden, that it is the coding problem.
I think that's what she was, you were talking about yesterday, the way people are recording the codes.
Any final questions, remarks?
It's, I was just checking that a paper published a couple of years ago by a group of Italian and French on multimorbidity and causes, multi-causes of death. And actually they were finding, and that's why it came to my mind, that there was an increase in the number of causes of death present in the death certificate with age, which is somehow on the other direction with respect to what you find in terms of dependence. So just a suggestion to have a look. Maybe I'm mixing up Grippo et al. In population studies. And so there was like, maybe there is a difference only in the methodology or in the data, because they used, I think, Italian and French data, but just a suggestion to.
And what was the open age figure? Because
it was 95 plus.
95 plus.
So, and then they went over different ages from 50 plus, like we've done in Italy in 2014. And so what they say that there was a rise in multimorbidity process over age. So that's, I found maybe it's just question of data and clinical habits in the two countries.
Yeah, I have never worked or anything with Italian data, but if you see other papers like from France, I don't know if I pronounce the name. This is yeah.
She's quote on that. So
yeah. And for France, you can see the shape like that. It is rising until 85, and then it is declining. So it is similar as in the US data and as in Czech data.
Okay.
But could it be possible that you have like more multiple conditions, but they are more random?
Yeah. I don't think they analyze in terms of dependence. So it could be the methodology, a different approach, but it just came to my mind and I had to look at that. Okay.
I have a general question because in the these shared studies, you were, how do we say, include other countries like France, Denmark, Spain, etc. And this presentation is based on US, yes, features. How do you compare all these countries together, where you make a big picture of based on all these countries, or because it depends, of course, on the availability of the data. So my question is, how do you compare still many years all these countries together? What could be the methodology?
First of all, we intend to carry out the same study when we get our hands on the data for the countries that you listed. So we had in mind Denmark.
Yeah.
We have ties to Sweden.
Yeah.
France, and probably to the UK. Probably.
Okay, probably.
So we applied for the Danish data, and we probably when Marie-Pierre comes back, because she has the relationships to Sweden and to France, we will also ask for the data. Probably it's going to be a collaborative effort. We won't be able to access data ourselves. There has to be a person there.
And before the Czechia.
And sorry, and for Czechia, we have the data.
Okay. Good.
Yeah, but of course we would like to focus on ICD-10 predominantly, because for Czechia, right? In what year did Czechia adopt the ICD-10?
Same as other developed countries.
Okay. So basically we will have similar age range for.
Okay.
Sorry, year range for.
Yeah. That's good. the US and the European.
Yes, with the US data, well, first of all, they were available, and
Yeah.
second, we wanted to test the methodology
Yeah, yeah.
and see what the outcomes are. And Elizabeth also had the access to the Czech data so that we can
Great.
check,
Yeah.
cross-check and compare. And well, it turns out that the patterns that we find are consistent across these so different countries in population sizes,
Yeah.
everything. Yeah.
There's a question online.
Are there any questions from our online audience? Okay, so if there are no more questions, Letty, thanks again for the great presentation.
Thank you.